So whenever you want to differentiate y equals something to the power of x here, in your mind think about e and think about the natural log. In the previous video, I've shown you how to differentiate this here using this method here. So now in this video, we're going to consider this method here. Okay, so to differentiate this here, your eyes should zoom into this x here. Try to convert this in terms of, well, in terms of e here. So try and convert this to base e. So just convert this bit here into base e. So that will then give you this. Okay, so this thing here is, well, your eyes should just zoom into the x only, and then try and convert the x into this here. Because if you think about it, remember our imaginary machine here, where you have e to the power of x, and then you've got the inverse machine here, which is the natural log of x here. Now, if you put any number in here, let's say you put x into here, then you're going to get something out, okay? And then if you put this something into here, then you're going to get x out. So that means that looking at this here, so that means looking at this here, if you put the inverse inside, so here what you've got here is you're putting the inverse into the original function here, so that should give you the original of whatever original that you put in here. So that means that you're putting this into this thing here. So in a way, this is like you having this here. Hang on. So this equals x, and I've done a video on this already. So try and track that down if you don't understand it. My point is that this thing here is the same as x. So this thing here is x. So when you try and differentiate this here, zoom into this bit here. Your eyes should just concentrate on this bit here, and then convert this to base e. Well, convert it to base e would be this. Okay, this is x. This in effect is x. So put this into this. Put this into this x here. That will then give you this. Okay. So when you're here, convert this base here to e, to the base e. So that will then give you this thing to the power of x. Now, whenever you have x to the power of a and then you power it to the b, it's just simply x to the power of ab. So you would just get this times this. So now this here times this. So yeah, so multiply the two together. That would then give you e to the power of this thing times this thing here. Okay. Remember that this here is not a constant because x is moving about. Well, this here is not a constant. Okay. So that will then so now you're at this stage here where this is being multiplied with this here. Okay. So now differentiate this. So now we've got to differentiate this. But just imagine this as being e to the power of something really complicated. So when you differentiate this, it will be e to the power of something complicated, and then you've got to times the differential of this bubble here. Okay, because this bubble here is a function of x. So you've got to so when you hang on. If you want to differentiate this, imagine it as being e to the power of something complicated. Okay, so when you differentiate this, so if you differentiate this here, it would be e to the power of something complicated, and then times the differential of the something complicated here. So hang on, differentiate this, so that would give you so imagine it as being like this. So differentiate this would be itself, which will be this, okay, and then you got to differentiate the bubble itself here. Well, the bubble itself would be, well, you got to use the product rule here, okay. So the product rule is differentiate this, leave this the same. So differentiate x would be 1, and then leave that the same, and then plus, and then leave this the same, and then differentiate this. Well, remember, if you differentiate this, it would be 1 over x. So it's you using the product rule here. So leave this the same, and then differentiate this. So that will then give you this. Okay. So yeah. So if you differentiate this, it will give you this whole thing here. So it's a combination of you using well, it's yeah, well, we've done lots of something similar to this before. Well, anyway, differentiate this. That will then give you dy by dx here. Okay, and remember, this thing here is actually x. This thing here is actually x to the power of x, because hang on, look at this here. We started out with y equals x to the power of x. Well, this x to the power of x is this thing here, and then, well, x to the power of x is this thing here. Okay, so this thing here, looking at this is x to the power of x. This is x to the power of x. This is x to the power of x. But then if you look at this here, this thing here is exactly the same as this thing here. So this thing here is x to the power of x. Okay, so basically, yeah, this thing here is x to the power of x, and then this here, well, this gets multiplied to the top, so it becomes 1 here. Okay, well, anyway, dy by dx equals this thing here. So let's just switch these two around. So at the moment you've got this times this. So let's switch these two around. So it looks I don't know, it looks slightly neater. So you've got this times this here. So overall dy by dx equals this. Okay, and if you get a graph plotter and plot it, it will look like this. So this here is your x to the power of x here, and this is your derivative. And it does kind of make sense, because looking at the red line here, you can see that here is a negative gradient, and then down here, looking at the blue line, it is negative. It's in the region of the negative. Okay, and then looking at the red line, the gradient here is 0. Looking at the blue line, it is 0 here. Okay, so it kind of makes sense. Okay, so dy by dx is this. Okay.